So we started with introduction. This was our first learning path, you can say. What is DevOps? So DevOps is a software development practice that combines the words development and the operation. So it's a culture. Now, it's about the methodologies. It's not about a tool or one specific tool or just learning about the tools. DevOps is important because it helps business deliver high quality products faster, respond to market demands quickly, stay competitive, innovate quickly, and respond to customer needs more efficiently. This includes team empowerment, cross-team communication, technology. There are some key goals which you need to achieve, like speed, quality, reliability, efficiency. Five main key goals. And you can achieve it with the help of these key principles: CI, CD, version control, agile, monitoring and logging, cloud, microservices, containers. Why containers are used and why containers are used and why they are so popular, what problem they are solving. So we were able to see that containers, they are lightweight, they are portable, they provide isolation, scalability, speed. And then we talked about the different services in Azure which are used to manage your containerized applications. And then we had a look at this life cycle where each and every resource in Azure is used, every service from Azure DevOps. And then we had a look at the Azure board. Azure board is for the planning, like you were managing the work items. Now, if I'll go to the portal, my DevOps portal, see, this is my Azure portal where I can create the resources. So I can here create a virtual machine, I can create a container instance, and in order to work with the DevOps services, I need to go to the DevOps portal. So what I'll do is I'll just stop the app services and whatever resources are there from my previous batch. So in order to reduce the cost. Okay, so now let's go to this project. This was our project. And here we can see that some of the settings are related to organization and some of the settings are related to the project. So in Azure DevOps, this is our hierarchy. We have organization. We can have multiple organizations. And then we have the projects. Now, on the other hand, in your Azure portal, about the logical grouping. Now, whenever we, let's say, work with the resources here, we have two types of grouping. We have logical grouping and we also have physical grouping. Physical grouping and logical grouping. Now, what is physical grouping? Physical grouping means that your resources are placed in a close proximity somewhere. So, when you create the resource, you select a region, right? You select a region. So, this means if you are selecting the same region, this means that it is a physical grouping. What is a region in Azure? Like I am creating a storage account. I select a region for it. So region is where, in the layman language, you can say that where data centers are there. So this is your region. So for your resource, whenever you create any resource, you select the region. Now, what is logical grouping in Azure? Okay, region we have understood. Okay, if they are in the same region or they are in the same availability zone. Availability zone are the physically separated buildings within the region. So if they are placed over there, then this means that there is a physical grouping. But now about logical grouping in Azure. So talking about logical grouping, you can have subscriptions. Subscription, what is it? Subscription is a billing boundary. This is your billing boundary. Now, within the subscription, you have the resource groups. What are resource groups? Resource groups are nothing but your logical containers. And within that, you have the resources, whatever you want to keep. You can keep the web app instance, the storage account, VMs, and how you want to create the resource group that you also have to decide. So, logical grouping means that you are keeping those resources together, you're grouping them together because they share some same attributes. Like I am creating a resource group and in which I'm keeping all the VMs together. So I have a resource group for all the VMs, or I can have a resource group for a particular project, like project 1 RG, in which I can keep all the resources which are used in my project 1. So this is your logical grouping. So that's how you can use your resource groups. Resource groups, you don't have to pay for them because they're nothing but like a folder. So you don't pay for the resource group. So that's how the hierarchy is. First of all, you have subscription, you have resource group, and within that, you have the resources. In Azure account, you can have multiple subscriptions. You can have subscription 1, 2, 3. Organizations may go with the different subscriptions for development, for testing, for uh, production. They can have multiple subscriptions. So this is also like allowing you to, go for logical grouping. Now, this was about how your hierarchy in Azure DevOps and in Azure Portal. And now in Azure DevOps, how you can configure the billing. Because some resources you can use them without paying anything, like Azure boards. You can use them. Azure repos, you can use them, they're free. But let's say for pipeline. Now, billing thing, we will discuss it later when we'll try to understand the concepts, like what is a parallel job in pipeline, how you need to pay for it, what are users, how do you buy licenses. But for now, let's say if in case you have to pay, then how are you going to connect your subscription to the DevOps for the billing? Because subscription is ultimately in your Azure portal. So for that, you can go to organization settings. So here you have organization settings. So here is my billing. Click on it and you can see this configure billing or change the billing. So you can select which subscription you want to select because you are connected to the tenant. See, if you go to Microsoft Intra, you can see the information of tenant that you are connected with. So what is a tenant in Azure? You work with the tenants and you get a default directory to work with. So, a tenant in Azure, it refers to a dedicated instance, or you can say partition of a cloud service. In our case, it's Azure. And this is used by a single organization or a customer. So it is actually a way to isolate and manage your resources. I have this Azure portal here, and currently I'm working with my default directory, and this is my tenant ID. Here I have subscriptions, I have resources, I can go to Intra ID, I'm getting an instance of Intra ID to work with. And this is my tenant ID. And I'm managing some set of users. For me, if I want to have another tenant, I can go and I can create a new tenant. So here, if you will go to tenants, directories and subscription, you can see the other directories that I can work with. I can switch to these directories and I can work with these particular directories. The directory you choose will impact the subscription. So we can say that these are the tenants. At a given time, we can only work with one instance. So when you create your organization, you select your directory. So what is this intra ID? Intra ID is a PaaS service. To manage your users. Every organization gets an instance of intra ID to work with. In our case, we are getting default directory. We'll manage some set of users over here. For users, we have default directory. Then we will also have the subscription here, which is used for the billing of resource. So in short, we can say default directory is to manage users and subscription is for the billing of resources. Billing of the resources. And at a given time, we are working with this particular instance. So we can say that this is our tenant. The dedicated instance or partition that we are working with. We can also create another tenant in which we can use another directory. We can name it and we can work with another subscription over there. So when you create your organization in DevOps, you select your directory. So for us, it is default directory. So what we have done as of now, this default directory is connected with our DevOps organization. Hence, when you configure the billing, you will be able to see this option. You will be able to see this particular subscription and you can configure it for the billing. And what else you can do is you can also add the users to your organization from this directory. So you have users now over here. I can add these users to my organization. So for that, I'll just go back here and I'll go to users. See, I can manage the users from here. You click here, add users, and then the directory to which you're connected, from that directory, you can add the users. Like here, I have all these users. Aid user 1, Anna Green, Isabel Garcia. If any user is not there, you can add it. Okay, let's say user 10. And then you can define the access level. Now, what is access level? See, we have four of them: basic, test plan, stakeholder, Visual Studio, subscribe. So let's open the documentation to have a table, okay, where all these differences are given. Azure DevOps user access level. Now, as we know that, first of all, let's understand difference between basic and the stakeholder. So, basic will provide you access to most of the features. You can assign it to users with a Visual Studio Professional subscription, Azure DevOps Server CAL, and to users for whom you are paying for the basic access in the organization. Now, when you select a user as a basic user, so how the billing is done? So, first 5 users are free of cost. You don't need to pay for them. But for the next one, like you are adding the sixth user, you have to pay $6 per user per month. So benefit is that as basic user, person who is having the basic access level can work with most of the things like sprint planning tools, advanced backlogs. Now all these things you will understand when we'll talk about these things in detail, like boards. Oh, okay, so boards we have already done. I think that was discussed yesterday. Okay, yeah, that was done. Okay, actually, I have two batches going on simultaneously, so I might get confused here. So here you have this sprint planning tools. Includes full access to backlog and sprint planning tools. Access to advanced homepage. Agile boards. You can work with agile boards. Okay. Now stakeholders, on the other hand, they have some limited access. Stakeholders, they cannot contribute to the code base. When a person, let's see here, we have this user who is Isabel Garcia. If she will try to sign in to the DevOps portal, she will not see repos in the project. Like this is your project. If she will try to sign in, and that too for private project, because when a project is public, when you select the access level for the project as public, anyone over the internet can view it. Like you have a GitHub project which is public, you can go and you can view the code. So similarly, these things are mostly for your private project. So in your private project, if you have a stakeholder, when they'll try to sign in, they will not see this repos. They cannot contribute to code base. They cannot approve the pull request. Most of the things that are from the pipeline, like creating, they won't be able to, perform all these things. Like here, yeah, stakeholders can't change the backlog priority order. Remember, we added the backlog items yesterday, product backlog item, and that was based on priority, if you remember. Stakeholders cannot change this priority order. They cannot assign the items to an iteration, like we were doing the mapping yesterday. So these stakeholders, they cannot do that, can't change. And also stakeholders, they can use drag and drop to create and change the work items, but only change the state field on cards. They only view the sprint capacity settings. They actually get limited access to boards and task board. No task board, we worked with that yesterday. We are changing the state from new, then it was under progress, and we use the drag and drop. So they also have limited access to these agile goals, your stakeholders. So here I think it should be like stakeholders can't use drag and drop to create and change, but they can only change the field state on the card because this is your field state. See, I have this board. You can go to backlog. This is my sprint and the task board. So this is drag and drop, and this is changing the state from the cards here. Next, you have basic plus test plans in which it provides the access to all features included in basic and the test plan. So here you have these test plans. Users will also get access to these in the test plans. Now, how is the pricing? It's $52 per user per month. Visual Studio subscriber assigned to the users who already have the Visual Studio subscription. They can have the Visual Studio Enterprise, Visual Studio Professional, or Visual Studio Test Professional, or MSDN. So you assign this particular access level to these people who already have this Visual Studio subscription and see what they can do. So this table is given for the comparison here about the different access level. Now, after that, after selecting your access level, you can select the project to which you want to add these people. So we have the project, which is, let's say, Wipro, and I can add these people to these projects. And then you decide the group. Now we have project contributor, project reader, and project administrator. So project reader, as the name says, they only have the read access. Then you have project contributor and project administrator. Now administrator have some more permissions, like they can manage settings like project settings, creating service hook. These things administrators can do. So you have to decide that which group you want to select. Now, if a person has the basic access level, you want to give him the access to, let's say, create work item. He can make the changes. So you put them under the project contributors. On the other hand, if there is a stakeholder user, you can keep him under the project reader because at the end he is not having that much permissions, the stakeholder. And yeah, then you have the administrators. So these are the DevOps groups which you have. And in order to know more about groups, how to manage them, how to manage the permissions, you go to policies, permissions. And here you can see the groups and their permissions. Now, for the identities for which you grant the explicit permissions, they are included in the security service group. Like I can add a person, John Green. Here is John Green, and then for him, I can define specific set of permissions, like what he can do with the service account, what he can do with Azure boards, whether he can create the field or not. Yes, he can, but I don't want him to create the field. Deny. So for the users for whom you define these permissions explicitly are under your security service group. And other than that, we have all these groups. Project collection administrator, project collection build administrator, valid users, build service account. So these are the permissions, set of permissions, and here you have the users, and you can view their permissions. Now, after adding the users, what you can do is click on add. So now let me share the pricing with you. Here is the pricing. So you can see that we have two things. We have server and we have services. So Azure DevOps services simply your software as a service solution. You take the help of the portal to access the services. Okay, and here in your server, you manage your infrastructure. If you want to go with the on-prem, you go with the Azure DevOps server, wherein you buy the license, the required license, you manage the infrastructure, and then you can work with the Azure DevOps. Okay, so that is your pricing. And see for services, the one that we are working with, you can also select your currency from here. And here it is. For basic plan, how much you have to pay. So it's 500 rupees per user per one. And first 5 users are free. So the moment you add the sixth user, this much you have to pay. For pipelines also the pricing is given. One Microsoft hosted job, one self-hosted job. Now the self-hosted job, Microsoft hosted job will be discussed in the pipelines. Then about Azure Artifact, GitHub Advanced Security. So I'm sharing this with you. Now that was a quick overview of how to add the users. Now let's move to the next topic that we need to discuss, and that is about service hook. Now both the things, service hook and service connection, you are going to find it under the project settings. So where you can find it under the project settings. Now first of all, what is service hook? Now service hook is used to communicate to external services. Send the notification of an event which has happened. Example, here you have added the work item. Okay, in the Azure board, the stakeholders they have added the work item. Now they want to send the notification. Users should be able to receive the notification on their Teams channel or the Slack channel, whatever your organization is using. Slack or Teams channel, whatever you are using for the communication for your team members. Here you want to send the notification. So what you are going to do is you are going to take help of the service hook. So this is used to communicate to the external services. Now here using this, what is the purpose? Purpose is to automate workflow by sending notifications or triggering actions in external systems like work item change, code commits, build completions. Now, another example. Now, this was one example that a work item is added and you want to send a notification. Next is you can also be working with Jenkins. Now, what happens? Organizations can also have CI in Jenkins and CD in Azure DevOps. There could be multiple reasons. Migration is happening, or maybe the entire CI CD was in Jenkins, but later they just moved to CD. Later they only moved the CD to Azure DevOps because Azure DevOps provide with the easier, let's say integration. Many features are available like deployment gates. Okay, because of these reasons, they are using Azure DevOps portal for configuring continuous deployment, CD pipeline. But CI is still in Jenkins. So what they can do is they can take help of service hook to trigger the CI pipeline in Jenkins. So any changes are made to the code, you want to trigger the CI pipeline in Jenkins. Trigger the CI pipeline in Jenkins. How this can be achieved? Again with the help of service hook. So if I'll just go to the project and you go to the project, you go to project settings. After that, go to the service hook. Now, after going to the service hook here, you can add a new service hook subscription. And from here, you can choose that with which service you want to integrate with. Now, here I want to integrate with Jenkins. So, see, these are the supported events, supported actions. Means if you want to trigger a generic build, so these are the events which are supported. Maybe build has been completed, code has been pushed. Click on next, select event type and the filter. Click on next and add your information of your Jenkins server. So Jenkins base URL, your username, user API token, build. So all these things you have to mention here to create a subscription. Another example, you can also create a service hook with the Slack channel. Slack is a platform for team communication. What all events are supported? All the events. And what are the supported actions? Post a message to the channel. So here I have a Slack workspace. For now, I'm connected to this particular project from Slack workspace, from the Slack channel. So let's unlink it first of all. Now, first of all, in order to work with this thing, to create service hook and to receive the notification, you need to first install the app in Microsoft Teams also. In your Microsoft Teams also, you see, here you have this option to add the apps. You can search for the app. This can be Azure Boots. You can install it. Okay, you can add it. Similarly, for your Slack also, you can first of all install the app. And for that, you need to click here Tools and Settings, Manage Apps. For me, I have already installed it. Now what I'll do, I'll just go to this channel and I'm going to link the project. First of all, to complete the sign in, you can use the command azbots sign in. I'm already signed in, so yeah, you're already signed in. I will link the project azbots link. And then from here, I'm going to copy the link of the project. So till here is my project link. So till my project name. Now I'm going to add the subscription. So what kind of notifications I want to receive? Click on add subscription and here area path. You remember we talked about area path yesterday. So from here you can add the area path and the event. So work item created. For that I want to receive notification. In case you want to receive notification about other events, you can add multiple subscriptions. Save it. Now here what I'll do is I'll go back to the portal and I'll create a work item. Okay, so from here I have got the notification. Now I can also create a work item from here itself. Easy boards create the work item, which is feature, feature 2. It has been created. Feature 2 has been created. Now if you want to do the same for the Microsoft Teams, steps are same, but only the commands which you are using here, this might be a little bit different. Like instead of slash azboards, you will be using at azboards. Let me share it with you. So here it is. See the commands which you can use. You can use the commands to link to your project and to create a work item. And here you have the azboards with Slack to manage work items. So that was about service hook. Now next is service connection. So ultimately what a service hook is for sending the notification or to define a trigger, triggering actions in external services. On the other hand, if you talk about service connection is a way to connect your Azure DevOps with the external services. Now, service connection has the information. What kind of information service connection is having? Service connection has the information about the credentials like tokens that will be used for authentication. Example, I'm creating a pipeline. Now, from my pipeline, what I want to do, I'm like creating a pipeline in which I have multiple tasks. Like, first of all, create an image, and then push it to the registry, Docker registry, or Azure container registry. Okay, let's say Docker. So, first of all, what I have to do, I have to create a service connection to connect to this external service. And that will have the information like tokens or your passwords. It will contain those credentials that will be used for authentication. So I will create the service connection, and this will be used to connect to the external service. Now here, if you want to create a service connection, you will go to the project settings, and after that you can go to service connection, and then you can create a new service connection. And let's say you want to get connected to Azure, that we have already like discussed yesterday. It's also covered in your lab. And then let's say if you want to get connected to Docker registry, how you can use it. See, click on next and then add your Docker ID, password, email, service connection name, and then you can create a connection to the Docker registry and you can use it in your pipeline. Because in your pipeline, you want to create an image and you want to push the image to the Docker registry. Similarly, in your pipeline, you will be working with an application. So and that will be, let's say, a .NET application, and you want to deploy it to the app service instance. Again, you're going to use the service connection. So service connection is a way to securely connect to the external services. You can manage, authenticate, secure connections between DevOps and external services. Now, in order to get connected to your Azure, you will use service principal. Okay, so first of all, service principal, there are two methods, automatic and manual. Automatic means a service principal will be created in the backend for us with appropriate permission. Manual means we will create service principal, assign the role, and then use it for the service connection. So first of all, what is service principal? So service principal is like a user identity. Okay, it's like the user account, which is used for the external services or automation tools to get authenticated and get authorized to work with the Azure services. If you have a user can use his credentials, username and password, and he can then have access to the services in Azure according to his permission. But now what about the resources? Or you can say what about external services? So if you have any external service like Terraform, you might be having another example we can take of DevOps only, Azure DevOps. So what we can do, we can take help of the service principle. So service principle is like a identity which is created, and this identity will be used by the external applications or external services. So when we create a service principle, we will get the ID, because what we are doing, we are ultimately creating identity, a unique identity. which will have app ID. And also, now we'll get the output. When we'll create the service principal, we will get the output. And that output will be containing the information of app ID, password, tenant ID, which we have to paste. We have to paste it over here. In Azure DevOps, when we'll create the service connection, here we have to add it. So ultimately, this service connection is using this service principal. And also for this service principal, we are going to assign the role, appropriate role. Now, using this service principal, we are going to get connected at the subscription level. You can also get connected to the resource group level. Okay, so I have this subscription. I want to create a service connection at this scope. And later in my pipeline, what I want to do, I want to create resources within this subscription. Create resources, manage resources. So for now, what I'll do, I'll give the contributor role, contributor of the subscription. And this contributor role will be assigned to the service principal. So let's go to the Azure portal. Okay, so this is the command. Okay, let's do one thing. Instead of creating a service connection at the subscription level, which is not recommended, let's try to create it at the resource group level, not subscription, because we have to be specific with the permissions. So we'll try to create a connection for resource group. Then we have the resources. So at this scope, we'll get connected. So again, we will give the contributor, but contributor to only resource group, not to the other resource groups which will be there. So this is the command that is used, AZADSP create, and then you define the scope, subscription, and then resource group. So we are only going to give the role for one scope, which is the resource group. So for that, I need to copy the subscription ID and the resource group name. And name I can also give, let's say, AZ400 RG connection. Let me also create a resource group first of all. Let me create it with portal only. So as you can see that the service principal has been created, contributor role has been assigned to that service principal for this particular resource group, and we are getting the output, the app ID, password, and tenant. Now this we have to paste in the external service. In our case, what is the external service? Azure DevOps. Now we'll go to the DevOps portal here and click New Service Connection, ARM. And because we are selecting Service Principal Manual, we we need to like add the ID, password, key. In case of automatic, you'll just select Create Connection, and then in the backend, a Service Principal will be created for you. So for now, I'll just copy the app ID. Here, Service Principal ID and the key. You can also use certificate for authentication. How you can manage that? Go to Intra ID, go to app registration, select your app registration, which was a service principal, which was AZ400 Wipro connection. Select it, go to certificates and secrets, and then manage. What do you want to use for authentication? The password or the certificates? Now I'll also paste the service principal key, and I'll mention the subscription ID, the tenant ID also. Verify and add the service connection name. Let's call it as AZ400 Wipro Resource Group Connection. That's how you add the service connection. And then in your pipeline, you can use the service connection. Let me show you an example from another project. But this service connection is only for this project. Service connection you set at the project level. So let me show you the pipeline from another project and click on this edit. See, for any task, or you can say any step, you select the service connection from here. So we will be using the service connection in later in our pipelines. So that was about your service connection and also your service principal, like how service principal is used for the service connection. So service principal is Azure identity used by applications, services and automation tools to access your Azure resources. Now let's see what is left. I talked about Azure boards, I talked about users, service connection, service principal. Yeah, adding custom columns. So in your Azure boards, if you want to add custom columns, so you can visualize your work using boards. And it's not just for one sprint. Like here, if you go to task board, they were for a particular sprint. But here it's not for a particular sprint. So here you just have three columns, new, in progress, done. For the features, you can also select the navigation level. But we cannot see Epic. So if you want to add that, go to project settings, go to your here team configuration, click on Epic. Go to board and select your navigation level. So if you want to add a you want to add the column. So I'm working on feature, but I only have three, new, in progress, done. I also want to add one more column, custom column. So go to columns, add column, in progress, and also testing. Let's say test. But now I'm confused that whether testing is under progress or testing is completed. So again, you can further divide your column into doing and done. Save and close. And here you have test, doing and done. But that is just for feature, not for backlog items like your product backlog and not for Epic. But this is for feature, doing and done. And then the final column, everything is completed. So this was about adding your custom column. So the next thing that we will be starting with will be about the version control system. So I'll just quickly have a 2-minute break. I'll quickly have water and then we'll resume. Okay, now let's start with the version controlling. What is version controlling? Version controlling is also known as source control. This is a practice of tracking and managing your changes to the software code because every time changes are being made to the software code. Version control systems, they help the software teams to manage the changes to the source code over the time because you have made some change and now you would like to go back to the previous version. How is that possible? That is possible with the help of version controlling. So you have two types of version control: distributed and centralized version control. Centralized version control was popular earlier. Yeah, and after that, the distributed version control came into picture. Now, in the centralized version control, uh, there is actually a central server which will store the version history of the code base. Now, developers must interact with this central server to commit the changes. So, you need to be connected to the central server 24/7 if you want to make any changes. Examples: subversion, SVN, that is also example of centralized version control. So, all version history was stored in this central server, and if this something happens to this central server, then your version history is lost. Then say your entire code base is lost. And also it requires a constant network connection to your server to perform most of the operations like commits, updates. So there was also, you can say single point of failure was there. Because if server goes down, no one can commit or access the history. So these were some disadvantages basically of your centralized version control. On the other hand, in the distributed version control, every developer has a complete copy of the entire repository, including the full history. Developers, they can work offline, synchronize changes with others as needed. Now, example of distributed version controls are Git, very popular, Git, and also Mercurial. Mercurial is also like example of the distributed version control. What is the difference between Git and GitHub? So GitHub is a web-based platform and Git is a technology. So it's a type of distributed version control. Now, what are the key features of this distributed version control? First of all, local repositories. Each developer, each developer is going to have the local copy of the code, will have the full copy of the history. And most operations can be performed offline. There is no need to get connected to the central server for all the time. And there is no like reliance on this central server. And also faster operations because you have the local repository. Better support for parallel development is there. So these are the different advantages of your distributed version control. Now, if you want to, let's say, clone the code locally, then you want to make the changes locally, you want to commit the changes locally. In that case, you need to work with the git commands. Okay. Now, as I said, git is a technology. Okay, so Git needs to be installed on your system locally if you want to work with the Git commands to clone the code, to push the changes to the main branch, or you can say to the remote repo, or commit the changes locally. So Git needs to be installed. On the other hand, GitHub is a web based platform to host your Git based repositories. GitHub or Azure repos. Because here in Azure DevOps, we will be using Azure repos. These are the platform for hosting Git-based repository. So you can try to compare it with a mailing system, like you send the mails, try to compare it with GitHub. And what are the platforms that you can use? You can use Outlook, you can use Gmail. So these are the web-based platforms. Now let's understand the working of Git. So here we have four things: working directory, the staging area, and the remote repository. Okay. So first of all, I'll just go to Azure Repos. Here I'm going to add a repository. So from here you have two options. You can create a new repository or you can, import a repository. So both the options are here, and manage in case you want to delete or any other things that you want to perform for managing it. Settings, okay, policies, the default branch names for the new repository. So that you can manage from here. If you want to disable the creation of TFVC repositories, which are for the centralized version control, you can manage them from here. Policy, file path validation, any reserved names, block the pushes that introduce files, maximum path length, maximum file size that can be pushed, selected from here, or any branch policy that you want to add. Protect current and future branches which match a specific pattern. So you can manage these settings from here under manage repositories. So if they are asking you that is there any way in Azure Repos using which you can uh, manage these things like here reserved names, file path validation, commit author email validation, and also this maximum file size. Yes, you can do it. So you also have to try to explore the portal more and more about, this Azure DevOps portal, because there will be many things which we will not be able to cover under just 20 hours in these 5 days. So before like preparing for exam, you may try to go through, most of the things. So here you can create a new repository and you may enter a name for the repository. I'll call it as demo repository. And then you can add a readme file. Readme file is not having your code. Readme is just for description. So that you can add here. And also your .gitignore files if you want to add. You can also select the template. So what .gitignore file has? The files that you don't want Git to track. Some files which are specific to the IDs or the build artifacts or your packages. It's a new Git packages. So you don't want Git to track these things. So you add them to the .gitignore. And when you select a template, you don't need to specify it. You don't need to mention from your side that what needs to be ignored. Okay, click on create. Now what I can do is I can just see I have one branch, main branch. I can clone it. You can select the IDE to which you want to clone it. So I can clone it to the VS Code. And select the local uh, path. So now I have cloned the repository and now I want to make the changes. For that, let's first understand what is git add, what is staging area. Let's discuss all these things. First of all, we had the remote repo. Okay, we have cloned it. Okay. So this is nothing but your Azure repos. Okay, then we have the local repo. We have cloned it. That is saved locally. That is our local repo. And then we have the working directory. Working directory, or we can say the working copy, which contains the files that you are actively working on. Changes here are untracked until you stage it. Right now, I'm working on this README file here. Okay, I'll add anything or I'll make any change. These changes are untracked for now. So you want Git to track these changes so that you can commit them locally. So we have to move it to the staging area. So the staging area, that is also known as index. This is an, you can say, a intermediate space in your Git where changes are collected before they are committed. So this acts like a preparation area where you can decide which changes to keep and which one should be like included for the next commit. So how the staging area like is added or how you can manage it. So the thing is that when you use the git add command, then changes are moved to the staging area. So before that, if I'll open the terminal, I'll write one command which is git init. It says reinitialized the existing git repository and see the path. So here our repository is having a .git folder. Now this git init command is used to initialize this .git folder. So this will have, all the information, this, git init. It will have the information of your configurations and about your staging area. So this .git directory is having these subdirectories about which have the information about branches and has information of configuration files like config and also about index. Now I told you staging area is index. So if you just move to this .git folder, here you have it. It has all these, description, config, index, which is a file, and then directories, which are like hooks, info, logs, objects, head, which is like a pointer. So if you create a, like right now it is saying reinitialized because we use that option clone to VS Code. So we do not need to initialize it manually. But when you're working like from, let's say from the scratch, you are, working on a project and you want to initialize this Git folder, you need to use this Git init. So now what I want to do here, I am in this working copy, okay, where I'm making the changes. I want to push the changes to the main branch. But before that, I cannot directly do it. First of all, I have to move them to the staging area. And then I will finalize my changes locally using the commit, git commit. So first of all, I'll remove all this. Change one. Let's add the command git add and then git commit. Initial commit. Okay. And I can view this history. So I can use the command git log. So these were the two basic commands, git add, git commit. Git add is used to move your changes to the staging area. Okay, we have moved it to the staging area. Now we also have a command which is git stash. Why is git stash used for? Git stash is used to temporarily store your uncommitted changes, staged and unstaged. So you can work on them, or you can like work on something else. Like you can switch your branch or you can pull the changes and you don't want to lose your work. So for that you use the git stash command. So here I can have change 2, let's say. I want to, let's say, switch to another branch, so I can save this. You can also type a message for your stash. So git stash -m and then a sensible message, just like commit. Now you can switch to another branch or you can pull the changes from the remote repo to stay updated, and then you can continue working, uh, you know, so can bring back these changes. And here we have that. Now what I'll do here, I'll just comment the changes. You can also use this user interface over here to commit the changes, to synchronize to changes, like push changes to the origin. Yes, so, and here you can also keep a track. See, right now we are working with the main branch and we are 3 commits ahead. And this is our remote repo. Now what I want to do is I want to reset the history. So you can use a command which is git reset, which is used to reset the history. So we have two things. We have a git reset, soft reset, and the hard reset. So what happens is when you work with the commits, so every commit is built on the top of the previous commit. So we have commits and we have the hash associated with them. It's a commit 1, commit 2, and commit 3. So you know, git reset is used to move the head and the current branch pointer to a specified commit. So currently right now for us the pointer is at commit 3. If I want to move the pointer at commit 2, I need to use the command git reset and then the hash of this commit 2. If I want to move the pointer to commit 1, I need to add the hash of commit 1, h1, like this. So we move the pointer. If I run the command git log, one line, okay, here I can see 3 commits. Initial, second, and third, and the very first one, added readme.mp. When we added the readme file. These are the ones which we have added. So now we will work with git reset soft reset. So in the soft reset, we move the pointer to a specific commit, but we keep the changes. We keep both the staging area and the working directory. We don't change them. They remain unchanged. So we uncommit the changes without losing them from the staging area. Like this change was made with change 3. Okay, so first of all, I'll run the command git reset on and then I'll copy the hash ID. You can see changes have been removed. Now if I'll again run the command git log, see now head is now at the second commit. So now the pointer is at the second commit, and change is also removed. The change that was introduced with this third commit. Now I will run the command which is git log and see I only have second commit. Third commit is removed. Now I can git reset. Now I want to move the pointer to initial commit. Now the pointer, oh, sorry. Yeah. Now the pointer is at initial commit. But changes are kept. So that is the difference between git reset soft and git reset hard. Git reset, the hard reset, it will clear the staging area and the working directory. And changes which you have made, they will be lost. But here the changes are kept. And these were the changes which were introduced. See, they are highlighted, added lines. But only the history has been removed from the logs. So now it will run the command. Like here, see, I only have initial commit, no second commit. But changes are kept. This is soft reset. So I can do one thing. I can also add another change. and I can use the command git push origin main. Origin means what? Origin is just the alias name for our entire URL. So we don't have to mention the entire URL again and again. Like here, this is our URL. If we want to use the git bash, what we do is we use the commands from the starting, git clone and then the URL. But in our case, we have just simply used this option clone in VS Code. That's it. So when you work with these repositories, origin is actually the alias. So git push origin main. And now you will see the changes will also be reflected on your remote repo and view the history also. See in the history you don't have second and third commit because we removed it. And these are your contents. Now I can edit and I can add some another line which is change 5. Now changes have been made to the main branch. Now changes have been made to the main branch and we want to stay updated with that so we can perform the pull operation. I can even use the command or I can use the user interface. So every time when you're pushing the changes to the main branch, it is recommended that you use the pull command also. So you first get synchronized with the changes and then you perform this operation, which can be, let's say, git push, pushing your changes to the remote repo. So here I will use this command, pull, sorry, push, yeah, pull. So pull from origin main. Edit. So I have kept the changes which were made in the remote repository. So that is your pull. So in order to get synchronized with the changes, so you can perform this pull. And whenever you want to make any changes, let's say change 6, what you can do is you can also use this pull and push. You can commit the changes locally and you can use the pull, synchronize. That option is directly available. Okay, so here what I can do, it says file failed to save readme compare it. Okay, I have kept the changes. And what I can do is I can add the commit message. Commit and synchronize. Synchronize means push, pull and push in case uh, any changes are made to the remote repo and you're not updated with that. Now I can see that I'll go back here and see the sixth change. And you can also view the history. Who made the changes, at what time changes were made. But now how a Git will get to know this? So for that we again you can use the command when you use the Git for the first time. Git config global user.name, which is change my name. Okay, for now, what is the name being reflected here? This is the name being reflected. Want to change the name? I can change the name. You can also change the email. How you change the email? Git config global user dot email. Email, I don't want to change it. I want to use my original email. Now you can see name has been updated. So for a file, let's say readme.md file, can view the contents of it, can view the history, and you can also view this blame option. Who made the changes and at what time the changes were made, along with the commit information. And you can also preview, okay? You can also compare two particular commits like commit 1 and commit 2. So initial commit, I want to compare it with the latest commit. Okay, these changes were introduced. You can view the history, compare any two particular commits you can compare. Now git reset, you have to be very careful while using the git reset because that will reset the history. But if you want to keep the history, you can use git revert. So let's add some error. Okay, I can go to the remote repo because when you work with the remote repo, changes are made to the remote repo. You don't prefer to reset the history. You should use revert. Now error has been introduced. What I can do? I can use the git revert. So go to history. You have this error commit. Copy the hash. Git revert. And whatever changes were introduced with this commit, they have been reverted. Now what you will do is you will just push the changes. You will not add any commit. You will not write any kind of message or anything. Just use the command git push. Revert the changes and then push them. And in the remote repo, what you will see, in the remote repo, you will see a new commit has been added. Revert error commit. So this commit is telling you that the changes which were introduced with this error commit, they have been reverted. So that's how you're also reverting the changes and you're keeping the history. You're not resetting or like changing the history. That was about the git revert. So git revert, git reset. When you talk about git, there are many commands. And in case you are new to git, people are already familiar. You don't need to go through all this again and again if you're using it daily. But those who are new to Git, you can refer to this Git cheat sheet. Okay, you're getting this error. Have you tried to use this command which I have used? Git config user.name, this one. Try this command. Whatever username you want to keep, and then the email you will configure. How to create username? Just type it, whatever username you want to create. See, in the lab, all the instructions are given. Okay, so before that, also use this command git config global credential.help. So refer to these steps. Okay, this is the link of the lab manual, and lab access has been already given yesterday. I hope you have the lab access.
Yeah, yes.
Okay, so you can try to perform it. Okay, great. Now I'll just add the timer. We'll have a short break, and after that, we'll continue with the next topics. Forget also, we first have to cover the branch policies, then Git hooks. What is Git LFS? These things we will be discussing. So I'll just start the timer and we'll continue after that. Okay, now what we were doing, we were making changes directly to the main branch, which is not recommended. Okay, so we don't make changes directly to main branch. What we do is we work with a branching strategy. So let's say this is your main branch, which has the code for production. So you don't make changes directly to this main branch. What you do is you create a new branch out of this main branch. Create this new branch out of the main branch, you make the changes, and then you commit your changes to the main branch. You merge your changes to the main branch. But before that, you cannot directly merge your changes to the main branch. You need to create a pull request, and that pull request will be approved by your approver. So here I can go to branch policy, click on branch policy. Okay, add this. Require minimum number of reviewers. So minimum number of reviewers will be one. Allow approvers, allow requesters to approve their own changes. Means I am requesting for a change and I can only approve it. So select this option. Then what you will do is you can also add this thing for traceability. Check for linked work items. Make it required. Block pull request from being completed unless they have at least one linked worked item. Now if I'll try to push the changes, it says remote rejected. You must use a pull request to update this branch. So what we'll do is we'll create a new branch out of this main branch using this command git checkout -b. Create a new branch and then move to that branch. Switch to that branch. So that is a feature branch. Now you are switched to a new branch which is feature 1. So test git push origin and not main, it will be feature. So this is the main branch. We move to the feature branch and it says feature 1 has been updated. Create a pull request. Create a pull request. Enter the title. So here you have to mention your pull request title and then the description you will be mentioning here, and you are going to add the reviewers and select your work item ID. See, I was working on feature 1. So let's say I have added this feature 1, or maybe the task, the individual task you're going to add. Click create. Now it says one approver must approve. Work item is linked. So green sign. You can approve the changes. You can approve with suggestions, or you can wait for author, or you can reject it. Approve. and then complete the merge. So now you have the changes. Changes are merged. And if you'll go to the main branch, you'll find the changes. And here you have the new changes. So this is your branch policy, which you can configure from here. Under your branches, you can go to branches and then you can set up the branch policies. You can also set a branch as a default branch. So that was about your pull request and how to, you know, restrict the pushes to the main branch using the branch policy. Now, next is about Git hook. First of all, let's talk about Git hook. What is Git hook? Git hook IO scripts that Git will automatically execute before or after a specific event which happens in the repository, like commit, pushes, merges, and checkout. So, your hooks are of two types: server side and client side hook. Now, the client side hook, they run on the developer's local machine. The server side hook, they are now being replaced. Okay, we don't now work with these server side hooks because now we work with the web based platforms which provide an alternative to the server side hook. Let's have a look at the client side hook. So, client side hooks are the scripts that run on the developer's local machine before or after a certain Git command. Example, I want to enforce some code style. I can enforce it with the help of pre-commit hook. Here it is, pre-commit hook. So you can ensure the consistent coding standards like running printers or formatters before any changes are committed. So you can write a script to enforce this code style to which hook? Pre-commit hook. So this name has to be same because pre-commit hook will run before you finalize your commit. Then we have the commit message hook, which is used to check the commit message. Like if I want to enforce a commit message format, I can do it with the help of the commit message hook. Example, in my organization, I have this rule where, whenever I am committing the changes, they need to follow a specific format, like the work item ID and then the description. So this is a format that needs to be followed. So what we can do is we can again take the help of the commit message hook, which is used to check the format of your commit message. Now from where you can configure these hooks. So your hooks are there in your .git slash hooks folder. Here you have your, you can configure your scripts. So within this hooks folder, you have these particular scripts like for pre-commit, post-commit, you select an event. Like you want your script should run before commit is finalized, go with pre-commit. You want it should run whenever when you have committed the changes, go with post-commit. Let's say you have committed the changes and you would like to, let's say, send notification. So, these kind of scripts you can write with the help of the client, with the help of the Git hooks. And again, if you talk about server side hooks, let's say you want to enforce some quality checks. You want to trigger deployments. Example, post receive hook runs after the push is completed. It can be used to trigger deployment or notification action. Now, instead of using this traditional server side hook, we are working with the web based platform like Azure Repos. And Azure Repos is providing us with the alternative. Alternative here, let's say to send the notification, what we are using? We are using service book. For triggering the deployment, we are simply creating a pipeline. So we generally, we replace this server side hooks with our services which are provided by these web based platforms. So let's take an example of the Git hook in which I'm going to check the format of the commit message. Okay, so this is our script for checking the format of the commit message. Okay, now here, I think this is not the correct one. This is some other script. Okay, this is the sample file within your hooks folder in the .git/hooks folder. The one which I have to use is this one. Now see, this is the sample script and we are writing a logic and that is to check the commit message and that should follow a specific format and that we are defining with the help of the regular expression. And also, first of all, we are using this shebang character. So shebang, this is used to indicate that it should run with bash. We can even write it in Python. In that case, we would have given the path to the Python interpreter. So that's what shebang character is for. This is the shebang character. So yeah, I'll just copy it. And here, see here, I have the hooks folder. You can even work with git bash over here. Okay, so here you have this hooks folder. Okay, and here you have these sample hooks. Now, if you want to create your hook, you can create it from here. Let's say, but name, has to be same. You need to take care of this thing. when you want to run the script, pre-commit. So you need to change the pre-commit hook. I want to work with commit message because I want to check the format of the commit message. So I'm adding it for commit message. We'll also make it executable. Now let's do one thing. Let's try to add a commit. Okay, so test hooks. Test the good hooks. Any random message I'm going to add. One thing. Okay, and here we are getting the error. Now that commit message hook is working fine. And here what we are getting? We're getting the error that commit message must match the format, the work item ID along with a description. But we are not following that, so that's why we are getting the error and we cannot commit the changes. In case we want to commit the changes, you have to use this kind of format. So let's use this format for our commit message, and it worked. So if you want to like enforce some kind of policies or anything, you can work with the hooks. So these are the scripts which run before or after a certain event. Now, if you wanted to have any other kind of script in which you wanted to run or some tests or you want to enforce some standards, so you can add it in the pre-commit hook, so that it will run before the commit is finalized. Now, in case you are working with large repositories, so first of all, you can work with the shallow copy and you can define the depth in your shallow copy. So for that, you use the command git clone and hyphen hyphen depth. Because right now we are just working with, we're just working on the demos. So it's not large repository. We just have few commits. Okay, that's it. But in case you're working with large repositories, you can try to go with the shallow clone. So shallow clone in the Git is actually a way to clone a repository without downloading its entire history. Because ultimately, if you're downloading the entire history, because in your real life scenario, you will be having thousands of commits, more than 5,000, 10,000 commits. So you want to manage this thing that you don't want to clone, or you can say you don't want to download the entire history because it will take up time and space. So you can choose to go with the shallow copy, or you can say shallow clone. So how do you define it? Using the command git clone hyphen hyphen depth and the depth. So depth means how many commits from the repository history you want to include. Depth of one means only the latest commit that will be cloned. So that is your shallow clone. Okay, very simple. Next is git LFS. You may also try it when you will perform the labs. In labs, they will talk about very basic things, not very advanced things, not the advanced git commands. So in case you want to try it, you may go with it. Next is Git LFS. Now, LFS is also another way to work with the large repositories. So, this is an extension for the Git. If you want to work with Git LFS, you will install it first using the command git lfs install. And then you will specify that git lfs should track which files. Let's say you have .mp4 files. Right? What happens that when you work with the large files, like you might be having media assets, you might be having the data sets or large binaries in your project that you want to store. But Git has a limit. Okay, there is a limit defined, which let's say you can only uh, push the file that is of 100 MB in size. And on 50 MB, you get the warning. But what if you want to work with these large files? So in that case, you can involve the LFS server. So what happened when you work with Git LFS? So an LFS server is involved. And here is your remote repo. So when you are pushing, so here you can see First of all, you will tell that git LFS. This LFS server should track which type of files, not MP4. And then git add large video. And then commit the changes. And git push origin main. So what will happen when you will push to the remote repo? Your files will be pushed to this remote repo. They will be stored here. But your large files are going to be stored to the LFS server. And in your remote repo, pointer will be maintained. Here, so in your remote repo, we have pointer files. So pointer will be maintained to the your large files. What happens when you clone? So when you download, so when you clone, the git LFS will download the latest version of the .jpg images or the version which is associated with that commit. Like you have multiple versions for that, let's say large video.mp4. In that case, what will happen? You have multiple versions like version 1, version 2, version 3, 4, 5. So when you will clone, Git will only download the latest version. And for rest, pointer files will be there. So that is the benefit of using the Git LFS. Git LFS was developed by Atlassian along with the GitHub. So not this one. Okay, this article is very helpful to understand about Git LFS. I'm sharing it with you. And why Git LFS is required. So that was about your Azure repos. Now you also have a lab for it. That is lab number 2. After after agile portfolio management and that you have the Git version controlling lab. Here it is version control with Git, agile planning and portfolio management. So all these labs you can perform. Next, we'll also talk about the pipelines. So in this version control lab, you will just be working with the basics of Git. Now next, we have to start with the pipelines. But before that, I will share a small quiz with you. And before that, if you have any questions, please let me know. In the meantime, I'm sharing a small quiz with you.
Yeah, I just try to create the service connection.
In- Mhm.
Uh, like field that before. With morning also I tried.
Did you scroll down?
I'm at the top and here save credentials.
Okay. Again, go to dev.azure.com
Same.
because we have to configure organization settings. See, this is the project. Now you can go back to organization settings.
Username. Okay, okay.
Click on it. Click on
Right, click
next.
Okay. And
Password.
not now.
Now continue.
Yeah, should I change the location?
No, it's fine. Leave it as it is. Click continue. Now use this project.
Yeah, it's
Use
fine,
this
right?
organization first because we have to configure organization settings. See, this is the project. Now you can go back to organization settings.
Okay. From here.
This ADO course organization. Click on that at the very top.
Okay.
Go to organization settings. Click on this show side menu at the top. You can see this arrow.
Show site
Arrow.
menu. This one.
No, on the left hand side.
This one, right?
No, just no. Below this, you can see this arrow, show side menu. You'll hover over it and it will display show side menu.
Okay,
This
side
back
menu.
arrow. And you see billing
Yes.
here.
Heading, yeah.
Okay, subscription is already added for billing purpose. Now go back. Go back. And what you have to configure now? Billing is
Service connection.
subscription. So go to project setting now. Project. eShop on web. This is the project that you will be using.
Here I need to click on pipelines, right?
No, not. No, click on organization settings. You have this arrow at the very bottom. Two arrows.
So,
Show more information. Click on it. Project settings.
uh,
Project settings.
project setting, yeah, this one.
Yeah. Click on project settings. Don't hide it again.
Okay.
Don't hide. Click on
Uh-huh.
project settings. This is the hide button. Click on show side menu at the top again. Yeah, show side menu. Now scroll down. Again, you can go to service connection. Service connection under pipeline. So yeah, here it is. Service connection. Create a service connection. Now follow those same steps that you performed. See, now you're able to see subscription.
Okay.
Okay, now you can try to create a service connection.
Yeah. Subscription here. Is what it- Yeah. That's it. Click save.
Save.
Yeah. It says whether you do not have the permission to create service connection.
Yeah, this you will be seeing this error for the first time. I also got this error yesterday
Okay.
when I was trying to demonstrate it. See, it's written
Okay.
also at the bottom.
Yeah.
You know that you will see this error. Try after some time.
Yeah, I will try. Thank you.
refresh it, or maybe, just refresh it and try it again.
Yeah.
Maybe after 10 or 15 minutes,
And
you should be able to do it.
yeah, I got it. And how to close this, or if I keep going, right? So whether the hours will detect from the subscription, how is it? Because here I can see the 10 launches, right? 4 launch has been expired. Only 6 are there. So if I
Okay.
want to close this, how?
Do one thing, cancel the lab.
Cancel, yeah, but
Okay, you
this
have
launch,
these, no, you have these, just give me a moment.
no, if I
At the
cancel the
top,
lab, right,
no,
then
no.
the one launch attempt will get expired because if you
Mhm,
saw here, right, 6 of 10 launch are only remaining for this lab.
mhm. Okay, can you go to back to the labs? On the top right hand side, you will see menu option, these three lines over there under the
No, this one,
instructions.
right?
Yes, menu, click on it, click on end,
And okay,
because you cannot save the lab. Cancel my lab. Don't end and mark it as complete. Cancel.
okay, cancel. Okay,
Okay. Okay, you can
if
go
I
back.
yeah, if I cancel, right, then attempt will go. My one attempt will go off, right? I cannot use that attempt, right?
But it shows 6 launches only.
Yeah. So from if I directly cancel from here, right? So one at launch attempt will get you can say used.
Launch attempt is generally when you like mark your lab as completed. For me, I use this option, and this attempt was not deducted. For me, it was showing 10.
Okay. So now this lab I haven't launched, right? So this showing as a 10 of 10 launches are attempts are remaining. But
Right.
here it's showing 6 of 10. So if I again launch it for more 6 times, so whether this lab will get locked,
Hmm?
all right? So if I again launch this lab for 6 times, so whether this lab will get
Okay.
locked?
Yes, after that, you won't be able to perform it.
Okay. Okay, I got it. Yeah.
So now what you can do is, I'll share the quiz link with you.
Yeah. Thank you.
Okay, I wanted to share the quiz with you. Okay, just give me 1 minute and I'll add the questions and share the quiz with you. 1 minute.
Yeah, yeah, sure.
Okay, now let's talk about the pipelines and why do we need the pipelines and what is the core idea behind the pipeline. Now, what is pipeline? In the simplest form, we can say that a pipeline can be thought of sequence of tasks and that are executed automatically after a certain event. like pushing code to the repository or creating a pull request. Now, in your pipelines, as I said, that you have sequences of tasks. Now, this is to reduce your manual work. Let's take example of a .NET application. So, what are the steps involved over here when you work with the .NET app? So, first of all, is to create a .NET application using the command .NET create. This I don't have to repeat again and again. So, I can create MVC based application, MVC architecture. Now, after that, we have the set of commands that we run. .NET restore to restore any third-party library, NuGet packages. .NET build to build your project. What is this build step required for? Build step we can simply say to convert our human readable code to the machine readable code. That is our build step. Okay, we get the executables over here that we will be ultimately using for our deployment. Okay, then we can have .NET publish, in which we can publish the output to a specific folder. And you can also include .NET test. If you want to have any testing, you have included unit testing. So what I'll do here now, create a new .NET application here, .NET. So the command it is successfully created. Here I can use the command now, .NET restore, to restore any third-party library with packages. And then you finally build your project. And you can also pass the arguments. What configuration you want to go with? Debug for the debugging purpose, and if you want to deploy it to production, it's release. So .NET build configuration release. The build succeeded, zero warning, zero errors. Now what I'll do here, I'll use the command .NET publish. I'll publish it to a specific folder. And here you have the output folder. And here you have your executable, and this will be used for the deployment. I'll put it on my web server where my site is hosted. We're using it for the deployment. But I am doing all these, steps manually. All these things I'm doing it manually, but I want to automate this process. That every time changes have been made to the code, developers they have pushed their changes. So those changes they should be immediately tested. The project should be built and then testing. Then it should be tested. So for this, I can create a pipeline. So, or to automate these tasks, I can create a pipeline. So, what is this? This is your build step. Simply here, we are not actually deploying it. So, as we discussed, that we have two things, we have CI and we have CD, continuous integration, continuous deployment. So, here, what we want in our CI pipeline, we will have restore, we'll have the restore task, build, even test if you want to add testing, and then publish. And here I will get the output as a part of my CI pipeline. And this output will be actually used in my CD pipeline for the deployment. And we'll look into this also, but later. Right now, let's try to create a CI pipeline, not the CD. So I will create a CI pipeline here with the help of classic pipeline. Now, when you talk about pipelines in Azure DevOps, you have two types of pipeline. One is classic and the other one is YAML. Classic means that you take the help of graphical user interface to configure your pipelines. So you don't write any code. On the other hand, in YAML pipeline, you write the YAML scripts to configure your pipeline. And here you take help of the graphical user interface. What is the benefit of using YAML script? Because it allows you to reuse your scripts. It allows for reusability. People can collaborate. You can go for collaboration. You can go for the version controlling. Like if I have this graphical user interface and in one of the tasks I'm changing something, how will people get to know that who made the changes, at what time changes were made? And like, because let's say your pipeline stopped working, so you need to know that what changes were made. So in order to have that proper version controlling, so you have to go with the YAML script. That is possible with the help of the YAML pipeline. So what we'll do, first of all, we'll complete all the things related to the classic pipeline. First of all, we'll complete this classic pipeline and then we'll move on to the YAML pipeline. Entire thing will complete for the classic CI CD. Then we'll move on to the YAML pipeline CI CD. That's how we are going to proceed. So first of all, I'll create the CI pipeline for this ASP.NET Core application using the classic pipeline. So I can go to the portal and here I will create a pipeline. Now you go to pipelines. Right now I don't have any pipeline in my project. Click on create pipeline. Use classic editor. And now when you want to work with the pipelines, you can have the support of templates. See, right now, let me do one thing. I'll import the project, import the repository in which I have my the sample.NET MVC app. Let me close all this. Here you have repos in the different project. So it's a public project, so it will not require authentication. In case it's a private project, maybe you are importing it from GitHub. In case it is a private project, you need to go through authentication. You need to complete the authentication. And for that, you will add the username, password, or instead of providing the credential, you can go with the personal access token. From here, you generate the personal access token. From GitHub also, you can generate the personal access token. If you don't know that how to create personal access token in GitHub, you can try to search for it in case you have not worked with it. So, but in Azure repos, this is how you create your personal access token. We'll be using it in the future. So right now it will not require authentication. It's a public project. Click on import. Okay, I think that was a private project from which I have imported it. This is TCS December. Okay, it's a private project. If I'll just change the settings, I'll make it public. See what happens. Let's see what happens. Yes, any question? See the hand is raised. Okay, so I have cloned the repo. One is for arm. Let me also do the other one. So I can go to pipeline and I can go to create pipeline. Use the classic editor and select your branch, which is main branch, and click on continue. Now I can select the template. Now I am working with an ASP.NET Core web app. So I can build and test the ASP.NET Core web app. Click on apply. And after that, you have to configure few things like the agent configuration and projects that you want to build or restore. Now, one thing is agent specification. For now, you can try to understand. See, we'll get into detail that what is self-hosted agent and what is MS hosted agent, and how to register a machine as a self-hosted agent. Now, when you work with the pipeline, see here, locally we understand. We were working on our laptop, we were working on our machine, and hence we don't need any other machine to build our project. But in case of pipeline, we need to provide with an agent. We need to provide with a target machine that is going to provide with the compute resources like CPU, memory. So that we need to configure. So we have two things now. We will call this as agent. Agent can be of two types: MS hosted and self-hosted agent. Self-hosted agents. What happens in MS hosted that when you select this option MS hosted for your pipelines, in the backend a VM is created for you. In the backend a VM is created and that VM is used to complete your task. And once the task is completed, your job is completed, VM is discarded. Now we have these terminologies. You can understand from now what is jobs. Job is collection of tasks. See, these are the steps. Or you can say these are the individual tasks, the smallest unit of work. So what are these? These are the individual tasks. And this collection of tasks is the job. Now, agent configuration you define at the job level. In your pipeline, you can have multiple jobs. Like you can have a build job and you can also have a test job. In case of CD, in case of CD, again, you can have your pipeline divided into multiple jobs, in which one job can be, let's say, to deploy to development, then to production. But you also take help of stages. We'll also discuss stages later. So, job is a collection of tasks. So you configure the agent for one particular job. For the job level, you configure this agent. Now, agent, as I said, can be of two types, MS hosted and self hosted. In the self hosted agent, you have your own machine. It can be your VM, or right now, what I'll do, the laptop on which I'm working, I'll make this as the self hosted agent. So, if you have any machine, you can register that as an agent. Register that as an agent and you can use it in your pipeline. Now, if I'll go back, I will select this agent specification from here because you are currently taking help of MS hosted agents. See, pipelines means MS hosted agent. Click on it and then define the agent specification. Because in the backend, the VM that will be created, what will be the specification of that VM? So let's say it will be Ubuntu. Now, what software will I get? Because in your machine, okay, I wanted to build a .NET project. This is my machine, and I'm sure that all the dependencies are downloaded. I have .NET SDKs installed. But what about the MS hosted ones? So we have a proper documentation for that. MS hosted agents. And here you have the link where you have the information of the included software. See, all these softwares are included. GitHub CLI, Azure CLI, AWS CLI, then your database tools, web servers. So according to this, you will decide that which agent you want to go with, which image you will be selecting in case of a self-hosted agent. Let's take an example. Let me see if Docker CLI is installed or not. Okay, Docker Compose, cached Docker images. So let's say if you want to install something, let's take example of .NET CLI only. You want to install it. So you can again use a predefined task. I have got a template, but other than these tasks, this is just a template. But other than these tasks, I can also take help of the other predefined tasks. So let's say install. See, if I want to install anything on my agent, I can install it. Install Docker CLI. See, Docker CLI installer. Install Docker CLI on agent machine. I can add this task. So this depends on my requirements. Okay, what I have to configure. Because in your self-hosted agent, few softwares are already there, but few might not be there, which you need to configure. Okay, so this is the link I'm sharing. First of all, you have the restore command, build command, And then the configuration. Configuration, we are passing the arguments here. Like there also we were using configuration release, configuration debug. So here we are taking help of variable. From where you can change this variable, go to variables, and from here you change it. Then we have the test. For now, I can remove it. Okay, but later in in your labs you will be working with these test task also. But for now, we are just removing it because I don't have the unit test for this project. But later for your eShop on web, you will be including that in your pipeline. And then we have the publish in which we are trying to publish the output. Now, why two things are there to publish, and then publish artifact? For that, we need to first work on self-hosted agent to understand better. For now, you can remember that we have restore, build, and publish, which is to publish the output. Like here, we were trying to do these things manually. Here, publish and then to save the output in the output folder. The executables we were getting like .dll, .exe, which will be used for the deployment. So now I can save it and I can queue it. I have given the information of agent that will be used. That is Ubuntu. So now click on run. Okay, now your job is running. Job is collection of tasks. Now we can see that the artifact has been produced. This artifact we are going to use for the deployment later. See, this is the output, the artifact. And this artifact we will be using for the deployment. So this was our build pipeline using the MS hosted agent. Now if I'll go to the pipeline, click on edit. Now you have two tasks over here. One is publish and one is publish artifact. Now what happens that when you have agent machine, doesn't matter MS hosted or self hosted, when you have your agent machine, here you have a folder that is work folder. Now within the work folder, you have folder 1. And then within this folder, you have a folder. Now this is the folder where your artifact is published in your agent machine. Now this folder, okay, this entire path is represented by a predefined variable. In Azure, we have some predefined variable which we do not declare, but they are already there by default. So this entire path is represented by your build.artifact staging directory. So this was your first step of publish. Then, because VM will be discarded, so there is a final location where your artifact is published. So that final location, or you can say final destination, was decided in this step, publish artifact. So we are publishing it to Azure pipeline. Or you can also select a file share or simply pipeline. So here where we have published our artifact as your pipeline. So when you will go to that specific run, you go to pipeline and you go to your project here. You go to pipeline, the specific run, you will see published artifact. Here you can see the information of artifacts, published and the consumed ones. Consumed one means the source code files, because here we wanted to build the project. So we had the source code files. Okay. So this was consumed. Published your app.zip. This will be later used in the deployment. Now, for how much time you can have this artifact over here saved? For that, you go to the specific run and you go to retain. Click on retain, view retention list and see pipeline retention settings. So this is retained as recent run for this pipeline forever. You can view retention settings. Days to keep artifacts 30. Days to keep runs 30. Days to keep pull requests, number of recent runs per pipeline. All these things you can manage from here. So if I'll go to the pipeline, now we can understand these two steps over here for publish. Okay. One is publish within your agent machine. So this is build.artifact staging directory, and that I have already told you what it is. And then publish artifact your final location. So that was a small example for the pipeline, automating the process. Right now, you're trying to automate these process, but we are, let's say we are running this pipeline manually. That's not what we want. So we can work with the triggers. Enable continuous integration trigger, which means any changes made to the main branch is going to trigger this pipeline. In case you want a schedule based trigger, like you want to run this pipeline on a specific time, go for a schedule based trigger. So I will have this continuous integration trigger. Any changes made to the main branch is going to trigger this pipeline. And here we are using .NET MVC project, and this is my main branch. So I will go to the app folder where I have the application code. I can go and make some changes to the views. And let's say edit. Commit the changes. And now what we have done, we have made changes to the main branch. So now the pipeline should be triggered. See, it is now triggered just now. And it is going to run again. So this is your trigger which you define for your pipeline. So using this, we are automating the process. Now we just made changes to the code, and this has triggered this pipeline which will ultimately complete restoration, build, and publish your artifact. And similarly, later we are also going to set the CD pipeline. So now tomorrow we'll first of all work with the self-hosted agent, and then we will create a CD pipeline using this classic pipeline, and then we'll move on to the YAML. So that was all from my side for today. Now, if you have any questions, you want to discuss anything, please let me know.